Good morning. Today we'll discuss about vector differentiation. Uh, Vector differentiation is a unit 4. So in this one, where before a small topic and small definition, the problems also very small only, and it will be an easy vector differentiation. Already you have learned these topics in intermediate vectors. Vectors, scalars, these all the things you are familiar with this most popular definitions. So gradient, normal vector, these things, divergent, directional derivative. You are a little bit familiar these topics in intermediate itself. Little bit detailed only we'll study in this now. So, so vector differential. Just a second. Vector differential and vector operator. Vector operator. Okay, so we have to learn two topics here. First, scalar point function, vector point function. So what is scalar point function? What is scalar point? Already you have learned in intermediate. What is scalar? A vector which has only a function which has only magnitude. It's known as a scalar point function. So scalar point function defines a function as a function which has only magnitude. Magnitude means a specific constant value. Only magnitude. It is defined in 3-dimension phi of xyz as xy plus 2x plus 3xy 3xz is called scalar point function. Okay, so this is an which has an only magnitude. You will call it as a scalar point function. Okay, for this one, 1, 2, 3 square root of, you will take it as a 1 square plus 2 square plus 3 square. That is what is the value you were going to get it here. That is a scalar point value. So second one is vector point function. So which has magnitude as well as a direction is called known as a vector point function. Vector point function defined as the function which has magnitude and direction. Okay, so and it is denoted as an a. So here you don't have an a. See here, I, J, K. You won't have the directions here. So here it's an a scalar point function. You will say here if you represent here function x, y, z. So x square y I bar z j bar plus x y square k bar. This has an a three directions along I x axis, y j y axis, k z axis. So the function has direction I j k and also magnitude. So this type of function you will call it as an a vector point function. This type of function you will call it as an a scalar point function. So after that one you will go write the definition as an a scalar, sorry, vector differential operator. Okay. So vector differential operator. So how you will be denoting the vector differential operator? It is denoted by del. You'll call it as an a del. Okay. So the del is denoted by I dou by dou x plus j dou by dou y plus k dou by dou z. Or else you can write it as an a summation dou by dou x. Like this you can write it down. It's an a vector differential operator. Okay. Next is an a next important definition is an a gradient of scalar point function. Gradient of a scalar point function. Okay. Gradient of scalar point function is nothing but an a let phi of x y z be a scalar point function of defined on defined in some region, Nana. That means some plane, any plane, region of space. Then gradient is defined as gradient of a scalar point function. Scalar point function is defined by del phi. Now how you will be writing? That is a gradient phi. That is the I bar dou phi by dou x plus u bar dou phi by dou y, k bar dou phi by dou z. Okay, so that means you will have the like this if a plane is there, a some plane. Phi is there a point where it's a normal vector. It's considered a plane surface phi. This was a phi, and it's a perpendicular vector. Grad phi is see this one. Grad phi denotes the nothing but it's a vector having normal to a point P. A normal to a point P, and phi denotes any surface. This is any surface. Phi is any surface where having the So grad phi is an any surface. So phi denotes an any surface. Grad phi denotes the normal vector at point P. That means normal vector perpendicular to an vector perpendicular to the surface. Vector perpendicular to an surface. So like that. This is an a grad phi. It's an a grad phi. It's nothing but an any surface which having an a normal vector to an a point P is known as a normal vector. It's an a point P is known as an a it's an a gradient of an a phi, gradient of an a phi. So how you're going to do the problems means first they'll ask us an a if phi is an a function of x, y, z like this they'll give x square y z. Find grad phi they'll ask. They'll ask us a grad phi. So what is grad phi ma? What is the formula? Grad phi. This one only now. I bar dou phi by dou x plus j bar dou phi by dou y plus k bar dou phi by dou z. Okay. So I is nothing but an dou by dou x of x square y z plus j bar dou by dou y of x y z plus k bar dou by dou z of x square yz. Okay. Grad phi it's nothing but I bar 2xyz plus j bar x square z plus k bar x square y. Okay. So like this, that means differentiating with respect to an first term with respect to an x, that is 2x. So next is an j, where with respect to y. So you have to get only other two terms will be an a constant. So x square y. So last thing is an a z. So x y z. Is this clear? Like this you will going to do the problem. Okay. Should I do the one more problem? After that I'll go for an a normal vector. Okay. So let if they ask like this one. Like this also they may ask the question x square minus yz plus z square is there. Okay. So if they ask in this way, so phi of xyz is equals to phi is equals to x square minus yz plus z square. Okay. Grad phi is equals to grad phi. Okay. I dou phi by dou x plus j bar dou phi by dou y plus k bar dou phi by dou z. Okay. So I is equals to dou by dou x of x square plus yz plus z square. Okay. J bar dou by dou y of x square minus yz plus z square plus k bar dou by dou z of x square minus yz plus z square. Okay. So next is an I into differentiating with respect to an x, that is 2x plus j minus z plus k bar minus y plus 2z. Okay. 2x I bar minus j minus z j. Okay. Minus or else plus only you can keep, and 2z minus y into k bar. Like this you're going to do the problem for an for calculating the gradient for phi. Then means grad phi they ask when they'll ask. Next is an unit normal vector. Unit normal vector. If what is that mean? If phi is a scalar point function and gradient of phi, that is grad phi is a normal unit vector to a given point, and it is denoted by an e. So if Phi is a scalar point function. See girls, everything I'm writing on the paper means why? Because if I say it will be an bouncing only. So if I write the definition on the paper, then it will be an what I am going to say you will be knowing. So I'm writing on the paper. So each and every definition. If phi is an scalar point function and gradient of phi, that is grad phi only, no? Isn't it? The then unit normal vector is denoted by E grad phi by grad phi. That is okay. That is equals to modulus of I is there. Means suppose A is the vector is there, na? So A1 I bar, A2 J bar plus A3 K bar is there. So this one A1 square plus A2 square plus A3 square. Like this you will be doing for a normal vector. That means magnitude you will be taking as a modulus like this. One problem I'll do. Okay. So find the unit normal vector to the given surface x square y plus 2x z is equals to 4 at point 2 comma minus 2 comma 3. Okay, so how you going to do means here first given surface is what is given surface ma y x square y plus 2xz is equals to 4. Okay, make it as an equation x square y plus 2xz minus 4 is equals to 0. Okay, let phi is equals to x square y plus 2xz minus 4 nana. So first we will be calculating dou phi by dou x. Differentiate with the partial differentiation with respect to x. 2xy plus 2z. Okay, dou phi by dou y is equals to x square. Dou phi by dou z is equals to 2x. Okay, so first calculate these points, then it will be an easy. So therefore grad phi, that is I dou phi by dou x plus j dou phi by dou y plus k dou phi by dou z. Okay, I 2xy plus 2z plus j x square plus k bar 2x. So normal vector at 2 comma minus 2 comma 3. So that is equals to a grad phi at point 2 comma minus 2 comma 3 we have to substitute. So I substitute the value 2 into x is x value 2 minus 2. Okay, x is 2 into grad phi this one. In this one I have to substitute this point. So I'm substituting 2. X value is 2, no? 2 minus 2. Okay, plus 2z, that is 2 into 3 plus j 4 plus k bar 2 into 2. So I'm going to get it as a minus 2i bar plus 4j bar plus 4k bar. Okay, grad phi, it's nothing but square root of minus 2 square plus 4 square plus 4 square is equal to square root of 4 plus 7 plus 16 is equals to square root of 36 is equals to 6. So what is the formula of unit normal vector? Unit normal vector grad phi by modulus of grad phi. So minus 2I bar plus kj bar 4k bar by 6. So 2 if you take it outside, minus I plus 2j bar plus 2k bar. Okay, so by 3. 6 no, it get cancelled. Directly I'm writing. Okay, it's a 6. 3 times 2 get cancelled. So what is the value of unit normal? Minus I plus 2j plus 2k bar by 3. Like this you're going to do the problem. Unit normal vector. How to find out? Is this clear? Okay.